All right, folks, here we go. Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video. Today's video is Stoichiometry 101 worksheet number 1. There's going to be a number of worksheets in this unit here. So I think you're doing good. Actually, before you watch this video, you need to make sure that you watch the video that is this video right here. That is, which video do you watch? You watch the stoichiometry flow chart video. Okay. Also, you also need to watch this video here before you start this, and there's a video right here. What is that video? How to determine the molar mass of a compound, worksheet number 2. You need to watch that one. I've given a number of examples therein. Another thing that you need is you actually need a periodic table of the elements. I'm using this particular periodic table of the elements. Most periodic table of the elements will do, but I'll be using this one today. So please watch the previous videos. Otherwise, this is not going to make a whole lot of sense. It'll be a hill of beans then. All right, so here we go. Let's get started on this problem. It's problem number 1. It says determine the moles in 0.28 grams of calcium chloride that has a formula unit of CaCl2. So here's how we're going to work with this. Number, units, formula. There's enough of that. So number, units, formula. That is going to be a key factor in every single calculation that we do. Number, units, formula. And I'm going to be using that frequently. Okay, that's going to be the theme of this whole unit on stoichiometry. That's very critical. All right, so let's get moving on this first problem. We are going to start with a number, the units, and the formula. So the number is 0.28 gram, and the units, excuse me, are grams. The formula is CaCl2. This is how this system works. We're going to start off with a number, that's 0.28, the units, grams, and then the formula, CaCl2. So number, units, formula. We're going to have that at every single step as well. All right, so what do we want? It says determine the moles. So that's what we're looking to solve for. I'm just going to highlight what we are solving for, and we're going to look for the moles. So this is how this system works. What we're going to do is we're going to do a monorail. That is a vertical stop in between this and the next step. I'm going to draw a horizontal line, and that horizontal line will go like such. Here's how this system works, and that is whatever the units are and the formula, I'm going to copy those units and formula, and I'm going to place them down in the denominator of this next term. So I'm going to have grams, because that's grams, CaCl2, because that's CaCl2. You should see that whatever units and formula are in the numerator, they will be the units and formula in the denominator of the next term. That is key and critical. All right. Now, we have grams. We want to go to moles. So what we're going to do is we're going to look at our flow chart. And again, I implore you to please watch the video that I have already made on this stoichiometry flow chart. So we have grams. We want moles. We have grams, which is a mass. We want moles. What is the unit conversion that I'm going to use? I'm going to use the unit conversion of molar mass. So I need to determine the molar mass of the compound of which I'm using, which in this case is calcium chloride. And again, I'm going to refer back to another video that I made. It says how to determine the molar mass of a compound, worksheet number 2. This video is posted online, and you need to watch this video first so that you can determine the molar mass of the compound. So it's 1 mole is equal to the molar mass in grams. So what do we need? We need a periodic table. We need to find calcium, and we need to find chlorine. Okay, so here is calcium. It is element number 20. Its molar mass is 40.08. Okay. Then here is chlorine. It is element number 17. There it is right there. And its molar mass is 35.45. So what we're going to do is we are going to determine the molar mass, that number will go here. I'm going to do this off to the side here. And so we have 40.08. How many calciums are in this formula? There is one calcium. So I'm going to multiply that by 1. Then chlorine is 35.45. How many chlorines are in this formula? 2. So I'm going to multiply that by 2. And I'm going to add up these two numbers right here. So I'm going to do this in my calculator off to the side. I got 40.08 times 1. And then I have 35.45 times 2. And I am going to get this number, 110.98. So the molar mass is 110.98. I'm going to round this number to the fewest number of decimal places that are originally of these two elements on the periodic table. There's 2 decimal places in calcium, 2 decimal places in chlorine, so this answer will have 2 decimal places. So this is the mass of what is the mass of 1 mole? That's why it's called the molar mass. So that means that moles goes up here, and it is a 1. And the same formula, CaCl2. All right. And then we're going to put an equal sign right here. And you should see that if you have done this correctly, then what happens here is that the grams of calcium chloride cancels out. That is, the units and formula in the numerator of the first term will cancel out with the units and formula of the denominator term. And then what units are you left with? Moles. What formula are you left with? CaCl2. Perfect. All right, now what we're going to do is we are going to plug this into our calculator. It's a really simple process here, and that is a 0.28. We're going to plug in times 1 divided by 110.98. A real simple, keep it simple, stupid process here is if it's in the numerator, you multiply. If it's in the denominator, you divide. So we're going to plug this into our calculator. I got 0.28 times 1, that's 0.28, and I'm going to divide by 110.98. And I'm going to get the answer of, let's see, I'm going to write this down in my, so this is my calculator number that you can see, it's times 10 to the negative 3. So I'll use a different calculator. Maybe you are more familiar with a calculator like this. And so let's give this one a try. 0.28 divided by 110.98 times 1, and I'm going to get this number right here. Okay. And so this number is in the calculator 0.00025229977. And now I need to round this number correctly. This number has leading zeros, do not count. This number has 2 significant figures. This denominator number has 1, 2, 3, 4, 5 significant figures. And this 1 is an infinite number of significant figures because it's a definition, that is 1 mole is equal to that molar mass. Captive zeros count. Leading zeros do not count. So the fewest number of significant figures is 2. I need to maintain these leading zeros, and then I'm going to have 2 significant figures. I'm going to round with that 2. That's less than 5, so I'm going to chop the number. So my number is going to be 0.0025. The units are moles, and the formula is CaCl2. If you saw on my other calculator, it was already in exponential notation. And so the other way of writing this would be 2.5 times 10 to the negative 123 moles of CaCl2. Both answers are perfectly correct. Nothing better about one than the other. You can go with either one. All right? Perfect. Let's go for problem number 2. Problem number 2 is determine the grams in 0.0045 moles of magnesium hydroxide. So again, what we're going to do is we're going to start off with a number, units, and a formula. The number that we have is 0.0045. The units are moles, And then the formula is magnesium hydroxide, MgOH parentheses Na2. Again, what we're doing is we're doing a vertical stop between this and the next term. We're going to draw a horizontal section here to help us out with this. Okay, and then what we're going to do is we're going to look at the units that are in this numerator term here. Those are moles and the formula MgOH2. So I'm going to copy these units and formula. I'm going to place them down here, mole of MgOH2, just like that. Okay, and you should see that the units and formula are the same in the numerator and denominator of the numerator of the previous term, denominator of the next term. Now, what we want is grams. Can we go from moles to grams in one step? Well, that's why we have this flow chart. Can we go from moles to grams in one step? Yes, we can. We're going to use the molar mass to do that. Again, this is coming from the stoichiometry flow chart. Very critical that you understand that. Okay, and so what we're going to do is we're going to look on here and how many moles? What's the number in front of the mole? It's a 1. It's a 1, the magic number 1. That's a 1. Okay, and then I'm going to get the molar mass of magnesium hydroxide. So what we're going to have to do is find magnesium on our periodic table. It is element number 12 that has a mass of 24.31. So I'm going to write that off to the side, 24.31. How many magnesiums are in this formula? There's 1 in this formula, so I'm going to multiply that by 1. Then I'm going to find oxygen. Oxygen is right here, and that is element number 8. It has a mass of 16.00. So 16.00. The question is, how many oxygens are in this formula? That 2 is outside the parentheses, so it distributes with the hydrogen and the oxygen. So there are 2 oxygens. Then what do we have next? Well, we have hydrogen, which is atomic number 1, and its molar mass is 1.01. So 1.01, and how many hydrogens? Again, I'm distributing that 2, so there are 2 hydrogens. So I'm going to do the product of these, and this will give me the, and then sum them up. That will give me the molar mass. So 24.31 times 2, 16 times 2, and then 1.01 times 2, and then I'm going to sum them all up. I will get 58.33. I need to round this number to the fewest number of decimal places, which is 1, 2, 1, 2, 1, 2, which is now 1, 2. Perfect. Now, this is the molar mass. So that is the mass of 1 mole, and it's the same formula, MgOH2. If you are doing this correctly, then what's happening is the units and formula in the numerator will cancel out with the units and formula in the denominator, if I could speak. All right, fantastic. And then we're going to follow the same process that we did on the previous problem, and that is if it's in the numerator, you multiply. If it's in the denominator, you divide. So it's 0.0045, 0.0045 times 58.33. And I'm going to multiply those together right there. And I am going to get a number in my calculator. Oh, divided by 1. I'm going to get a number in my calculator. That's 0.262485. I'm going to round that number. Just 58.33. Yes. Then what we're going to do is we're going to round this number, but we have to look at the number of significant figures. Remember, leading zeros don't count, but they're placeholders. This has 2 significant figures. This has an infinite number of significant figures, and this has 4 significant figures. So this answer will be rounded to 2 significant figures. 1, 2, I'm running with that 2. So it would be 0.26. The units are grams. The formula is MgOH and a 2. Perfect. So it's 0.26 grams of magnesium hydroxide. All right. Let's see if we can hammer through problem number 3. So I'm going to slide this up here so that we have more problems exposed for us so that we can do. We have a total of 8 problems here on this worksheet. I think we can actually handle this. This next one here is determine the moles in 4.3 grams of sodium sulfate. So I'm going to start off with number units formula, 4.3 grams of Na2SO4. I'm going to draw a vertical stop, and then I may draw a horizontal line between this and the next term. It helps me to separate them. All right, perfect. What are the units in the numerator? They are grams. What is the formula in the numerator? Na2SO4, Na2SO4. I'm going to go from grams to what? Moles. So I'm going to go over here to my flow chart. I'm going to go from a mass, which is in grams, to moles. Okay, so moles will be in my numerator term. That's moles of Na2SO4. You should see that we're not actually changing the formula. What's the number in front of the mole? It's a 1. Always a 1, folks. That's right. It's a big fat 1 in front of the mole. All right, fantastic. Then this number in front of the grams for sodium sulfate, what is it called? It is called the molar mass. So I need to calculate the molar mass of sodium sulfate. Sodium is my periodic table. That is right here at atomic number 11. It has a molar mass of 22.99, 22.99. How many sodiums are in this formula? There are two. There are two sodiums. Then there's one sulfur. That is atomic number 16, and that has a mass of 32.07. 32.07. How many sulfurs are in this formula? There's one. Then there's oxygens. Oxygens is atomic number 8. It's a molar mass of 16. 16. And how many oxygens are in this formula? 4 oxygens in this formula. I'm going to take all these here, multiply them as is appropriate, and then add them up at the end. So it's 22.99 times 2. 32.07 times 1, and then 16.00 times 4, and I'm going to add that up, and I'm going to get 142.05. I'm rounding this number to the fewest number of decimal places, which is 2, 2, 2, and that's why this has 2. All right, perfecto. This has 2 significant figures. This has infinite number of significant figures, and this has 1, 2, 3, 4, 5 significant figures. The least number of significant figures is 2. I'm going to be rounding to 2 significant figures. I'm going to take 4.3. I'm going to multiply it by 1 and then take the 142 and divide by that. And I am going to get another decimal value again. So let's plug this into our calculator. So 4.3 times 1, which is 4.3, divided by 142.05. That's equal to 0.030271031. That's what I get in my calculator right there. That's what I get in my calculator right there in exponential notation. I'm going to round to the fewest number of fewest number of significant figures, which is 2. 1, 2. I'm rounding with that 2. So I'm going to get 0.030. That 3 counts, and that trailing 0 counts because there's a decimal. The units are moles, and the formula is Na2SO4. And just like on the previous problems, you should see that the mass, the units and formula in the numerator are the same as the units and formula in the denominator of the next term. I'm going to cancel those out. That's why I'm ending up with moles. All right, we're just going to scroll this down, and you should see that problem number 1 and 3 are very similar in their process. You're starting off with the mass. You're using the molar mass. That's in the denominator. You end up with moles. Bingo. Perfect. You guys are doing a fantastic job. Let's hammer through problem number 4. Problem number 4, it says determine the grams in 0.00023 moles of ammonium sulfide. And you should see that problem number 2 and 4 are very similar. The number is different and the formula is different. Otherwise, the process is exactly the same. So again, we are going to start off with a number that is this number, 0.00023, and the units, that's moles, and then the formula NH4 2S. We're going to draw a vertical stop and then a horizontal section between this and the next one, just like that. Again, just like what we have been doing here, we're going to highlight the units and formula right here. That will be units, moles, and formula, NH4, parentheses 2, and an S. So these units and formula that are in the numerator and denominator of the next term, they will cancel out in just a moment. We're going to go from moles to grams. So we're going to look at our flow chart and we're going from moles to grams. We're going to use the molar mass. That's our key term here to do the conversion. What is the number in front of the mole? It's a 1. What's the number in front of the mole? Yell it out in front of that phone or computer that you're looking at. It's a mole. It's a 1. That's right, folks. Now we have to get the molar mass of ammonium sulfide. So we're going to bring out a table and we're going to find nitrogen. That's atomic number 7. That's 14.01. 14.01. And how many nitrogens are there? 2 nitrogens. And then there's hydrogens in this formula. That's a molar mass of 1.01. 1.01. And how many hydrogens again? There's 4 times 2. That's 8. And then there's one single sulfur, and that's 32.07. 32.07. And there's one of those. We're going to multiply, then we're going to add on all these here. Okay, cool. Let's see if we can do that here. We got 14.01 times 2, and we got 1.01 times 8, and we have 32.07. We're going to add all that up, and we're going to get the molar mass here, and let's see if we can do that. So 14.01 times 2 plus 8 times 1.01 plus 1 times 32.07. We're going to get that 68.17. So 68.17, and the units for this are grams, and then the same formula, NH4 2S. All right, you should see that the moles of ammonium sulfide cancels out, and I'm going to be left with grams of ammonium sulfide. I'm going to plug this into my calculator here. So it is 0.00023 times 68.17. Okay, and I'm going to get that number that you should see there. That's that partial number. I'm just going to do it on my other calculator just to make sure. 68.17 multiply, and yeah. So the number that I get in my calculator is as follows. That's 0.015671. Hopefully you're getting the same number. This number has 2 significant figures. This has an infinite number of significant figures. And this has 4 significant figures. So the least number of significant figures is 2. You should see a theme in this worksheet here. 1, 2. I'm rounding with that 6. That's 5 or greater. I'm going to add 1 to the preceding digit. So I'll have 0.016. The units are grams. The formula is NH4, parentheses 2, and an S. Perfecto. And you should see that problem number 2 and problem number 4 are very similar in their nature. Okay, so we're going to slide this on up here because we got some more problems to do. We got 4 more problems to do. We are ready for an advertisement break by our sponsor, and our sponsor is the Crazy Hat Chemist. That's me, folks. I am the Crazy Hat Chemist. I am the place where you are to watch real chemistry videos and learn real chemistry to prep you for college. Okay, that's what my goal is here today, or one of them. All right, so this next problem here is problem number 5. Now we're going to do something slightly different here. So I'm going to highlight again what we are solving for, determine the number of molecules. Now I want you to see that on problems 1 through 4, we weren't determining molecules on any of them. Those were moles or grams. Okay, what do we have? Well, we have 0.017 moles of calcium phosphate, that's Ca3. PO4, parentheses, and a 2. A vertical stop in between this and the next term, like we have always been doing. And then a horizontal line here between this and the next term here to get us all set up straight. Okay, so in order for this to work, these units of moles are going to go down here in the denominator, and then the same formula that's in the numerator will go in the denominator. That's Ca3, PO4, parentheses, and a 2. And we are doing the same thing that we've been doing this whole time, and that is nothing has changed in regards to units and formula, units and formula. Okay, awesome. Now what we're going to do is we're going to pull out our flow chart again. In our flow chart, we're going to go from moles to molecules. I have moles. I want to go to molecules because that's what the question is asking. So now I'm looking at this section of the flow chart. I'm going to go from moles to molecules. What's the number in front of the mole? As always, that's right, folks. It's a 1. It's the number 1 in front of the mole. So let's write that down. That's a 1 in front of the mole. I want to go to molecules. So MOLEC. That is the abbreviation for molecules. Same formula, Ca3, PO4, parentheses, and a 2. Okay, and now I need to figure out what the number is associated with the molecules when going from moles to molecules. So just looking in this section right over here, I'm going from moles to molecules. Okay, what's the number? Avogadro's number, which is 6.022 times 10 to the 23rd. So it's Avogadro's number for the number of molecules. So we're going to write that down. 6.022 times 10 to the 23rd. Okay. You should see that the moles of calcium phosphate cancels out with what's in the numerator and denominator. Okay, that is perfecto. This number has 2 significant figures. This has 4 significant figures, and this has an infinite number of significant figures. We're going to plug this into our calculator, and I'm going to show you how to do this here. So pay particular attention. Let's slide this over. And here we go. We're going to clear that out. We have our first number, which is 0.017. And then we are going to multiply by Avogadro's number. So it's going to be a times, and then it's 6.022, 6.022. And then depending on the type of calculator you have, but on this particular Texas Instrument 30X2S, what you're going to do is you're going to look at this 7 and find the button above it. It's the x to the negative 1. But I want really, that's the reciprocal button. What I want is this EE, the capital EE. Some calculators have a capital E that you use, and that like is on this calculator, it's just an E. But on this calculator right here, it's this EE. Well, it's a yellow one, so I'm going to hit this yellow button right here, and then that will give me the second shift, and then I'm going to hit this button, and I will get an E in my calculator. And now I'm going to type in the exponent, which is 23. I'm going to hit 23, and then I'm going to hit equals. And now I should get the number that I have. I'm going to write that down. So 1.02374, and it says times 10 to the 22, times 10 to the 22. Okay, so hopefully that makes sense for you. So 0.017, 6.022 times 10 to the 23rd, and we're going to multiply those, and it's 1.02374 times 10 to the 22. And I need to round this to 2 significant figures. So 1, 2, I'm rounding with that 2. That'll be 1.0 times 10 to the 22 molecules of calcium phosphate. Perfecto. I'm going to scroll this out just a little bit so I got a little bit more space. All right. Beautiful. You guys are doing a fantastic job. We've got 3 more problems to do, so keep on going. So this next one, it says determine the number of moles. So what are we solving for? Moles. What do we have? We have 2.3 times 10 to the 25 molecules of sodium hydroxide. So 2.3 times 10 to the 25 molecules of sodium hydroxide, which is NaOH. Vertical stop, and then a horizontal line to help us out here. You don't have to use a ruler. I'm using a ruler so it looks nice and pretty for you, the viewer, but whatever you want. It says molecules of NaOH here in the numerator. That means that molecules of NaOH need to be in the denominator of the next term. That's what we've been following this whole process. That's why it's called stoichiometry for chemistry, or unit analysis, or dimensional analysis, if you will. Okay, and then from molecules, I want to go to moles. So I'm going to look at my flow chart here, and I'm going to just do a little fold on my flow chart. So we're looking at this single section here that's going to be really important here. Okay, I'm looking at this single section. So I'm looking at this section right here. I'm going to go from molecules to moles. Molecules is Avogadro's number. The moles is a 1. Like always, what is the number for the mole? 1. What is the number for the molecule? Avogadro's number when going back and forth between molecules and moles. So I have moles up here in the numerator, and it's same formula, NaOH. And what's the number in front of the mole? It's a 1. What's the number in front of the molecule? 6.022 times 10 to the 23rd. Right? This is why the molecules of NaOH cancels out, and then I will be left with my answer there at the end. So what we're doing is looking at significant figures. 2.3, that has 2 significant figures. This mole has a 1 for that, and this 4 significant figures right there. So we're going to type into our calculator 2.3 times 10 to the 25 times 1 divided by 6.022 times 10 to the 23rd. On the last problem, I didn't divide by 1 because you get the same number. So I'm also not going to multiply by 1. Okay. All right. So here we go. We're going to type this in. So watch very, very carefully. It's 2.3 times 10 to the 25. Do you hit the multiplication button now? No. Do you hit this button? No, 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 do not do that. You need that EE button. So it's the second button, the EE, and then the 25. That is the number 2.3 times 10 to the 25. I did not hit the multiplication button. I'm going to slide this over. This number, Avogadro's number, is in the denominator. So I'm going to hit the divide button. Now I'm going to type in 6.022, 6.022, and then I'm going to hit times 10 to the 23rd. Again, you do not want to hit the multiplication button. You need that EE button, and that is right there. That EE button lets you know that it's times 10 to the what? 23rd. Now I'm going to hit the equals button, and then here's the number I get right there. I'm going to write this down. That's 38.1932927. I'm going to round this to the fewest number of significant figures, which is 2. That's 1, 2. Rounding with that 1, I will have 38. That's it. The units that don't cancel out are moles, and the formula is NaOH. Number, units, formula. Perfect. All right. All right, folks, we're going to do the next problem here, number 7, and it says determine the number of molecules. Okay, determine the number of molecules, and I have 0.0062 moles of ferric hydroxide. And that is FeOH parentheses and a 3, a vertical stop between this and the next term, a horizontal line, so to keep my ducks in a row here. So I help you, the watcher, out, the viewer out. Whatever are the units and formula in this numerator term will be the same units, moles, and the same formula, FeOH3. So those are the same. I'm following that whole same process this whole time. What do I want? I want molecules. So that lets me know that molecules needs to go in the numerator term, and then it's the same formula, FeOH3. Now I need to look at my flow chart. I'm going to go from moles to molecules. From moles to molecules. What's the number in front of the mole? It's a 1. So let's pop that in here. What's the number in front of the mole? It's a 1. What's the number in front of the molecules when going from moles to molecules or molecules to moles? It's Avogadro's number, Emile de Avogadro, and that is 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. Okay, perfect. I'm going to slide this on up here just a bit here, and you can see this. And we're going to key this into our calculator here. We're going to clear this, and we have 0.0062 times, because this number is in the numerator, 6.022 times 10 to the, which is that E button, 23rd, and then an equal. We're going to get this number in our calculator, which is 3.73364 times 10 to the 21. I'm going to just do this on my other calculator just to make sure I have not made some screwball error. And it looks like we're looking good. So we need to round this number. This number has two significant figures. This number has an infinite number of significant figures, and this is four significant figures. So we need to round this number right here to one, two significant figures. I'm rounding with that 3. So I got 3.7. 3.7 times 10 to the 21 molecules of Fe parentheses OH and the 3 ferric hydroxide. We are canceling out the moles of ferric hydroxide and moles of ferric hydroxide from the numerator to denominator. You should see that this problem number 7 is very similar to the problem number 5. It's the same setup, and that's because you start off with moles and you end up with molecules. Now we're going to do problem number 8, and problem number 8 is just like number 6. What are we looking to solve for? It says determine the moles. So we are solving for moles, but what do we have? We're going to start off with what we have, 1.8 times 10 to the 24 molecules, MOLEC, of potassium oxide, and that is K2O. Vertical stop between this and the next term, and then a horizontal line to make it look pretty for you, the viewer. That's right, folks. All right. So whatever is in the numerator for units and formula will be in the denominator of the next term for units, that's molecules, and formula, K2O. All right, so these two terms here are exactly the same. It allows us to cancel them out in just a little bit. Okay, and then we have molecules to what? What do we want? Moles. So we want moles, and it's K2O. So we're going to look at our flow chart here, and it says moles to molecules. What's the number in front of the mole? It's a 1. Absolutely, it's a 1 in front of the mole. What's the number in front of the molecule when going between molecules and moles? Is Avogadro's number, which is 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. Excellent. We're going to cancel out our units and formula of molecules of K2O, molecules of K2O. We're going to get a number in our calculator here, and that's 1.8 times 10 to the 24. And we're going to divide by 6.022 times 10 to the 23rd. And then we are going to get a number for that. We're going to type this into our calculator here. So it's 1.8 times 10 to the 24. And then this number here is in the denominator, so I'm going to say divide by 6.022 times 10 to the 23rd. Remember, you're not hitting a multiplication button, it's the E button. Is equal to this number here, 2.98, and we're going to write this down so that you can see this here. So 2.989040186. Okay, and this number here has two significant figures, an infinite number of significant figures, and four significant figures. So we're going to round this to 1, 2 significant figures. I'm rounding with that 8. That 8 is going to add 1 to that 9. Oh my, that 9 becomes a 10. I'm going to add 1 to the next digit. It'll be 3.0 because I need 2 significant figures. Moles. Those are the units that don't cancel out of potassium oxide. And then that is my answer. Oh my gosh. You guys have done a fantastic job. This is 8 problems. I'm going to zoom on out so you can just briefly take a look at this whole worksheet here. We have done many things on this worksheet, and this is what we've got for our worksheet right here. That looks beautiful. We've done molar mass calculations. We've converted from grams to moles. We've converted from moles to grams. We've converted from moles to molecules, and then we've converted from molecules to moles. So we've done many different conversions here today, and I hope you are enjoying this. I am most certainly the Crazy Hat Chemist. Oh yeah, the Crazy Hat Chemist. All right, I'm going to see you next time for another video, and I hope you have a delightful day. Talk to you later. Bye for now.